Did you send an email yesterday about the quiz that you forgot to mention? Because I can mention it now if you want me to.
Go ahead.
Just to let you know on the quiz, I think Dr. Logan and I think a lot of you are probably sitting down to your computer and trying to do the quiz just kind of like you're doing a normal quiz, without books and without notes and without friends. And if you are doing that, you can use whatever resources you have available to try to get the right answer on the quiz. It's not a closed book quiz, it's not a closed note quiz. You can even work together. Now, you need to work out all the problems. You can't just have somebody do the problems for you. But if you need to use the internet, if you need to use whatever resources you have available, you can use on the quiz. So we just don't want you sitting down and thinking you have to try to do all of this from memory, just from what we've talked about in class. So I know Dr. Lowe wanted to clarify that yesterday, so I just thought I would mention that before we got started this morning. All right, so this time is yours to ask questions about homework, or even if there's a quiz problem that's kind of stumping you, we can start working it out on the board and get you started. Did anybody start the quiz from yesterday? Ashamed to raise a hand. Oh. All right. So any questions on? Let's start with section 1.
What is it?
1.5.
Quiz like 1.5 or what?
1.5 in the beginning, 1.6.
Yeah,
That's
the
it?
first half of 1.6.
Wow.
Because we didn't get to arc cosine and arc sine and those kind of things yesterday, so. If there aren't any questions, I guess I'll just have Dr. Lowe come down and lecture. Keep going.
Yeah, I think let's get started, right? No.
All right, section 1.5 was exponential functions. Any specific problems giving anyone trouble?
I don't care what number, but can we do one that's buying the world? That'll make sure.
Sure. I'm sure there's several of them were assigned, so. Do a couple of them. Okay, you have several laws of exponents. Now, as long as you have the same base, apply the law of exponents. So in this case, when two exponential numbers are multiplied together with the same base, what do we do with the exponent? You add them. Okay, so this becomes the same base, and you add the exponents. If you add those two exponents, what do you get? Okay. You get 9 to the 1/2, which is what? Which is what? Okay, if we look at 15, (25) to the 1/8 power, and all of that to the 4th power. In this case, what law of exponents would you use? What would you do to the exponents here? You multiply them. You get 25 to the 1/8 times 4, which is 1/2. 25 to the 1/2.
How would you do that?
2 to the square root of 3 times 7 to the square root of 3. What can you do with that one?
We'll just find the bases and keep it. Would it be 2 squares of 3 then? 2 times 7 to the square root of 3.
Okay, can you multiply bases? What if you had, let's look at one that's a little bit, I guess, more common. What if you had 2 to the 3rd power times 3 to the 3rd power? Does that equal 6 to the 3rd power?
You have to solve either side of
I mean, what's this? This is 8
it. 8, 1 7.
and 27. How much is 8 times 27?
200. Trust you. 216.
So what is 6 to the 3rd power? 2 how much? Is 216 as well?
36.
36 times 6. Okay? So those are equal. Right.
48.
So
Yeah, put it in like that, it's pretty important like that.
do what?
With the 2 and 7, that makes make more sense too.
It's just like you have the square root of 2 times the square root of 3, square root of 6. Okay, was that enough law of exponents?
We do 21 or 24, one of those assigned, I'm not too sure.
No. It's finding the domain and range.
That's just that E, I wasn't too sure.
And we can look at, let's look at 21.
So the way, 2 part.
Okay, what would be, what x's can we plug in there?
That would be after that. 0 to the 100? No way. Is it 2 to the infinity?
What?
2 to the infinity, I guess, or negative 2?
Is this ever gonna be a negative?
No.
No, because if we look at the graph looks like this.
Should be 0 to infinity.
Right? So this, the y value for this is never going to be negative. So what we can plug in there is what, negative infinity, positive infinity, and the with zero? So this is never gonna be zero.
Guru Spiegel. Be careful on the range there.
Yeah, I'm just thinking
Okay.
that. Is ever gonna go below two, the denominator? So what's the lowest this is gonna get to?
Hold on. Remember, that's a fraction. So the lowest the denominator gets deals with the largest the function value gets. How small can the denominator get? No. The smallest value in the denominator it's when e to the x gets as close to 0 as possible, right? So that makes the whole fraction equal to what? Okay, so when the denominator is the smallest, the value of that function is the largest.
Okay. We got these.
I get what you're saying.
So 0 to 1.
Because
On the bottom, so it makes it.
But it's gonna get, yeah, this is gonna get larger, right? So 1/2 is the greatest value.
negative, so 0.
Sorry about that.
Oh,
Does that make sense?
how is the domain negative because if you put in negative,
Because you can put in whatever x you want, because you don't have to worry about this. This is a fraction, so the input that we have to worry about is whatever would make this 0.
if you take e to a negative number, it's just going to be another fraction, isn't it? Yeah, just be small.
Do what? No, I graphed this part only. I didn't graph the whole. But as this part gets really, really, really big, the denominator of the fraction gets really big, so the whole number gets really, really small. Okay, we don't have any other questions on 1.5. Do we have any on 1.6?